Hi guys, and welcome to today's video on further gradient of a straight line. A new video in this further maths course that is going to build with the module on, what's it called? Graphs and relations, he says, looking off screen, just to make sure he knows what he's talking about. If you are new to my channel, it's really good to see you. You will see over there on my left a little logo. Maybe it's on my right. It's on my right. A little logo of my website that you can go over and join, MaffsGuru.com. It's free to sign up, and there are videos there, downloadable notes, time-coded videos, and so much more to come. Exam question solutions. The world really is your oyster. If you can also head over to YouTube and subscribe to my YouTube channel, I would be deeply grateful to you because, well, it's the only way I know that people are watching these, and hopefully they are useful to you. Now, by the end of this, we're going to know what the gradient of a straight line is, how to find the gradient of a straight line, and know that gradients can be positive and negative, and understand about special lines. And in fact, it's the special lines that throw people, funnily enough, with this. You've probably been doing this since year 9, finding gradients of straight lines. Hopefully, if I asked you what the formula was, everyone would scream at me. Well, no, please don't scream. It's rise over run. But there are other ways of doing it, and if I'm honest with you, probably makes a little bit more sense to do it in a slightly different way. So hopefully the learning of this video is going to blow your mind. Now, I normally start with a recap, but as I say, there is no real recap. Now, if you heard me say a moment ago about the further maths course, don't worry about it. It's all good. If you are in a completely different country outside of Australia, which is fine, this is universal. Maths is a universal language, and in fact, as someone says, maths is a constant. LOL. Moving on. So what is a gradient? Now, a gradient is basically a number given to the slope of a straight line. I call it the measure of slopiness. Yeah, if I was here on my straight road and this is my bicycle, I'll try and draw a bike really, really badly. That's not too bad. Yeah, and there's me trying to sit on it with my little feet and my arms. Then if I'm going along a straight road there, then I'm stoked. Thank you very much. That's the only time you will ever get me on a bicycle. Trust me. Yes, because anything other than that, and I get a little bit scared. Don't worry, it's fine. Dealing with it with a therapist. My nan used to live literally at the top of a hill like that. Yeah, I used to walk up it and it was horrendous. To try and get from the shops to my nan's house, this hill was nothing like you've ever seen before. Would I cycle up that? Not a hope. Yeah, why? Because I'd have a heart attack. I'd be gone, thank you very much. So that there has a gradient. That hill there can be described as some sort of number in terms of a gradient. What about if I was to go down the hill the other way? Yeah, still no. It's a lot of fun, isn't it, going down hills on bikes until you get to the bottom and you can't stop. Or you're going so fast you can see the speed of light. Or, you know, everything's just stopping. You're time traveling, in fact. I need to breathe. What is going on here? But the point of it is this line here has what we call a positive gradient. Why? Because it's sloping up. If it's sloping down, it has what we call a negative gradient, all right? So that's first thing's really, really important. Gradients can be expressed in all sorts of things. On signs in Australia maybe, and I think the UK, they tend to draw sort of triangles, I think, and they give it like a percentage. They say a gradient of 3%. Don't know about you, doesn't mean anything to me. Yeah, gradient of 45%, that's more like this one here. That's my nan's hill going the other way around. That's fairly terrifying. A 45-degree line is basically like that. But we can give gradients in terms of fractions. So we can say 1 on 2, we can say 2 on 3. We can even give gradients as whole numbers. So we could say the gradient of 4. But what you need to remember is every single whole number is actually a fraction because we can divide it by 1. Now, writing it as a fraction makes life so much easier to me. Why? Because I can think of it in terms of rise and run. And again, we'll come back to that in a moment. So yes, as I say, you have been taught probably over and over again, gradient is rise over run. That if I have some sort of line, I choose 2 points on it, and it can be any 2 points, and I draw a wonderful little right angle triangle, and I count how many squares it's risen, and I count how many squares it's run, and then that gives me my gradient because I do the number of squares of the rise divided by the number of squares of the run. That's one way of doing it. I think this way here is truly funky. The idea that y2 minus y1 over x2 minus x1. Now, what does that mean? If we look at gradients, let's say 1, 4 and 7, 10. There are 2 points there. And I can use those 2 points. I could plot them on a graph. I could count how many squares up and count how many squares I go down. But what we realize, or what we know, is that coordinates have what we call an x value and a y value, right? And they're in the order of the alphabet. That makes life easy. Now that x value is different for each of those coordinates. So how do we differentiate that? Well, we call this x1 and we call that y1 to stand for coordinate 1, and we call this x2 and we call this y2. So hold on a moment. When I now have my formula for gradient is equal to y2 minus y1 on x2 minus x1, then all it's telling me is take the second y value, which in this situation is 10, and subtract the first y value, and this situation is 4. Take the second x value, 7, and subtract the first x value, which is 1. Now the whole thing here is you've got to get these the right way around. If you do the second coordinate minus the first coordinate, easy peasy lemon squeezy. Funnily enough, it doesn't actually matter, and I'll show you why in a moment. So 10 minus 4 gives me 6, 7 minus 1 gives me 6, and 6 divided by 6 gives me 1. But what if I did it the other way around? Well, let's just check. I'd have gradient is equal to, now in this situation I'm going to do 4 minus 10. I have to do the y values. I have to subtract the y values, but it doesn't matter. I can do the first y value, take away the second y value, and then the first x value, take away the second x value. Now all I'm going to end up here is negative numbers. 4 minus 10 is minus 6, 1 minus 7 is minus 6, and when I do a number divided by itself, I in fact get 1 again. So I actually really like that second gradient formula. It's going to make life a lot easier in later videos. So here are some examples of finding gradients. Find the gradient of this line. Now again, to find the gradient, you need to be given 2 coordinate points. And here we go. We've got 1 coordinate point there, which is 0, 2, and we got this coordinate there, which is minus 2, 0. Now again, I don't try and do this in my head. I write them down because I now know that my gradient is going to be y2 minus y1 on x2 minus x1. So my y2 value is 0, minus my y1 value is 2, and I have minus 2 minus 0. So again, if I'm going too fast here, just pause, stop the video, rewind me if you need to. Sorry that you got to listen to my voice again, but just give it a go. And 0 minus 2 gives me minus 2, and minus 2 minus 0 gives me minus 2, and in fact, therefore, my gradient is 1. Now that's using y2 minus y1. You can also use rise over run. How many squares has that gone up? 2. How many squares has it gone across? 2. And so in this situation, if I was to use gradient is equal to rise over run, I would do 2 divided by 2, which gives me 1. The only thing you've got to make sure here is that you also then remember which way the line is sloping. Because this is a positive slope, I need to make sure that my answer is positive. I don't normally write the positive, but I quite like the y2 minus y1. It does all the hard work for me, so long as I can subtract the numbers in the right order. What about this one here? Well, let's do the points again. So I've got 0, 3, and funnily enough, people make the biggest mistakes here by putting the coordinates the wrong way around. Remember, it's x followed by y. And this one here is 2, 0. So I now have my gradient is equal to y2. Let's do the formula. I've already got it, but let's write it out. x2 minus x1. So the second y value is 0 minus the first y value is 3. The second x value is 2 minus the first y value is 0. First x value is 0. 0 minus 3 is minus 3. 2 minus 0 is 2. And lo and behold, there is my answer. Now, is that gradient negative? Does it slope down? Absolutely, I should cocoa. And so that formula has done all the hard work for me. Otherwise, in this situation, I would have to do gradient is equal to rise over run. Okay, so we know that if I make a right angle triangle, that's 3 rise and 2 run. So 3 on 2, but I have to remember that it's negative and put a minus sign in it. Now again, it's totally up to you which way you do it. Later on, I think you're going to have to start doing the formula that I'm using. Now there are a number of special lines that you must know about, and they're a bit of a trick. So find the gradient of the line which connects the point 1, 3 and 5, 3. Okay, so the gradient is equal to y2 minus y1 on x2 minus x1. Okay, so 3 minus 3, so y2 minus y1 on 5 minus 1. Well, 3 minus 3 is 0, 5 minus 1 is 4, and we know that 0 divided by anything is 0. Now actually, a 0 gradient means it is a perfectly horizontal line. That's what a 0 gradient means. And if I went back to my idea of my bike at the beginning, That's why I like going along these. Zero gradient. Love, 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 love. How would I know that? Well, funnily enough, if I was to draw a set of axes, and we'll call that X and Y, and plot these points, 1, 3 would be here. So there's 1, and there's 3, and 5, 3 would be here. And if I was to draw a line through those points, it's perfectly horizontal. Now, funnily enough, this equation of that line is actually called y equals 3. And we're going to come back to that in a slightly later video. Why is it that way? Because all of the y values along that line are equal to 3. But the important point here is horizontal lines have a gradient of 0. What about this point then? Well, it may look the same, but it really isn't. So I've got my two coordinates. So my gradient is equal to y2 minus y1 on x2 minus x1. So 10 minus 1 divided by 3 minus 3. 10 minus 1 is 9. 3 divided by 3 is 0. And now we have a problem, because if you put 9 divided by 0 onto your calculator, it's going to come up and it's going to say undefined. Why? Well, basically, your calculator is saying, hold on a moment, the gradient of that thing is vertical. It's a straight line. It's like running at a wall. Don't do it. Bad idea. Knock yourself out. Concussion or horrible. And so if we was to again, that was terrible grammar. If we were to again draw these points, 3, 1, 3, 1 is there, and 3, 10 could be here. And lo and behold, if I join those 2 points together, they are in fact a perfectly vertical straight line. Now, again, the equation of this is x equals 3. We'll come back to that again a bit later on. But vertical lines have an infinite gradient or an undefined gradient. So I could put here that sideways 8, or just say the gradient is undefined. There we go, ladies and gentlemen. That is the end of this video. Thank you very much. There's a lot more to come for this particular module for the Further Maths course. If you haven't already done so, please subscribe to my YouTube channel. Again, it just lets me know you're watching. I'm never going to be rich and never going to be famous. Otherwise, head over to MaffsGuru.com and sign up for me over there. Right, well, it's been good seeing you. Hopefully I'll see you again. If not, you stay safe. And if I do see you again, you take care. All right, bye-bye. I'm signing off.